Today we are talking about right triangle trigonometry. So we're going to be reviewing the 6 trig ratios. I know that you learned this in geometry. This is no different from what you guys did in geometry, but it's been a couple of years since you've done that probably, so we're going to review it today. But this is exactly what you did in geometry a couple of years ago. So there are, to any right triangle, we can there are 6 different possibilities, 6 different combinations of the sides. We can have the hypotenuse divided by the opposite, so we're talking about ratios, so we're talking about fractions. Hypotenuse over opposite, opposite over hypotenuse, hypotenuse over adjacent, adjacent over hypotenuse, opposite over adjacent, adjacent over opposite. There are 6 possible combinations of ratios. Those 6 possibilities create our 6 trig ratios. Sine of theta is always the opposite side over the hypotenuse. You could think of that as opposite over hypotenuse. Okay? Cosine is always adjacent over hypotenuse. Okay? Tangent is always opposite over adjacent. Cosecant. Cosecant is always hypotenuse over opposite. So, since sine is opposite over hypotenuse and cosecant is hypotenuse over opposite, they are flips of each other. So, cosecant is the flip of sine, and sine is the flip of cosecant. They are reciprocals of each other. They are reciprocal functions. Okay? Secant is always hypotenuse divided by adjacent. So it is the flip or reciprocal of cosine. So I could say that secant is 1 over cosine, and cosine is 1 over secant. They are reciprocal functions. They are not inverse functions. They are reciprocal functions. And the last of our trig ratios is cotangent, and that is adjacent divided by opposite. It is the flip of tangent. So cotangent is 1 over tangent, and tangent is 1 over cotangent. Notice that every time I have to have this angle here. I have to have the angle every time. It makes no sense to just put a secant without having an angle next to it. Okay? No sense. So never do that. You must always have an angle. Alright, these are the 6 trig ratios, and to remember those, the device that helps us remember that is SOHCAHTOA. This is sine, and sine is opposite over hypotenuse. The C stands for cosine. Cosine is adjacent over hypotenuse. The T is for tangent, and tangent is opposite over adjacent. SOHCAHTOA. Alrighty? And if you know those, then you can get to the reciprocal functions. Okay? Alright. So let's do a little example here. We have this right triangle. They mark theta for us up here. They give us two sides of the right triangle. What can we do to get the third side of the right triangle? We can use the Pythagorean theorem to get this. So I'm going to call this x, and I'm going to set up x squared plus 2 squared is equal to the hypotenuse squared. Excuse me. And we're going to solve this for x. So I'm going to have x squared is 3 squared minus 2 squared. And then I'm going to square root both sides, ignoring the negative, of course, because we're talking about sides of a triangle. So notice what we did here. The 3 was the hypotenuse. If I'm looking for a leg, I take the hypotenuse squared minus the other leg squared under the radical, under the square root. So this is going to be the square root of 9 minus 4 is 5, so we get the square root of 5 here. So that leg is the square root of 5. So tangent of theta, that is opposite over adjacent, because SOHCAHTOA, opposite over adjacent. Here's theta. Here's theta, the opposite theta. It does not form theta, it's opposite. Opposite is square root of 5. Adjacent, not the hypotenuse, the other side that forms theta is the adjacent side. So this is adjacent here. That is opposite. And of course 3 is the hypotenuse. So square root of 5 over 2 is tangent of theta. Cosine of theta. So SOHCAHTOA, so it is adjacent over hypotenuse. The adjacent side is 2. The hypotenuse is 3. Sine of theta. So opposite over hypotenuse. SOHCAHTOA. Opposite is square root 5. Hypotenuse is 3. Now we're going to use reciprocals to get these. Secant is the reciprocal of cosine. So since cosine is 2 over 3, secant will be 3 over 2. Secant is the flip of cosine. Cosecant is the flip of sine. So we'll have 3 over square root 5. And when we rationalize that denominator, multiply top and bottom by square root 5, we get 3 square root of 5 over 5. So cosecant is the flip of the reciprocal of sine. Cotangent is the reciprocal of tangent. So 2 over square root 5. Again, we're going to rationalize that. And we're done. So cotangent is the reciprocal of tangent. Kids, remember that one. These are the ones that kids like to get mixed up. I think it's because secant starts with S, but cosine starts with C, whereas cosecant starts with C and sine starts with S. So kids want to like put the two C things together and the two S things together, but they don't go together. Secant goes with cosine. Alrighty. Do another one. Oh, we're going to be familiar with some of the Pythagorean triples. There are a lot of Pythagorean triples, but we need to just remember a few of them. The one that everybody likes and is familiar with, it seems, is 3, 4, 5 right triangles. The two legs are 3 and 4. The hypotenuse is 5. Of course, the hypotenuse is always the longest one. The next one I'd like you to recall is 5, 12, 13. And then there is the 8, 15, 17. And just one more, 7, 24, 25. If you don't remember these, you're just going to need to use the Pythagorean theorem. And it might get a little messy getting up there with these bigger numbers. Okay? So right here for this triangle, if I know that a leg is 8 and the hypotenuse is 17, then I know that this remaining leg, I don't have to work out the Pythagorean theorem, I already know that that remaining leg is going to be 15, because that's an 8, 15, 17 right triangle. Okay, here's theta. So the 8 will be the opposite side. 17 is, of course, the hypotenuse, and 15 will be the adjacent side. So cosecant. Well, up here I started with cosecant. In my mind, cosecant is the flip of sine, and sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. The hypotenuse is 17. The opposite is 8. Cosine. That is adjacent over hypotenuse. So 15 over 17. Tangent. Opposite over adjacent. Opposite is 8. Adjacent is 15. Sine. Sine is opposite over hypotenuse. Opposite is 8. Hypotenuse is 17. Cotangent is the flip of tangent. We already did tangent, so I'm just going to flip it to get cotangent. Secant is the flip of cosine. I already got cosine, so I'm going to flip that to get secant. Okay, we're going to do a little calculator work now for number 3. So grab your calculator. You can pause this and get your calculator if you need to. Alright, first of all, we are in radians, so make sure, go to your mode and make sure you're in radian mode. Our calculators default to radian mode. If you have a different calculator, you're going to need to figure out how to get it in radian mode. Okay, but we're in radian mode. Sine of pi over 3. Here's the sine button right here. Make sure you can see everything. There's the sine button. Got a bunch of glare on there. Oh. I'm going to try to turn off this light, see if that helps. No, not really. I'll try to do this. Maybe that worked. Maybe. Okay, sine of pi over 3. And the directions say to give at least 5 digits after the decimal point. So 0.86602. That's 5. If you want to give one more, that's fine. At least 5 after the decimal point. Okay, cosine of 3 pi over 7. That will be 0.22252. And then if you want to give one more, that's fine. Tangent of pi over 9. That'll be 0.36397. Okay. Cotangent. RTI 84s don't have a cotangent button or a cosecant or a secant button. Some of the other calculators do, so if you have one that does, go ahead and just use that. But for cotangent in our calculator, I'm going to type in 1 divided by tangent, because I know that cotangent is 1 over tangent. That's what I'm typing in. So 1 divided by tangent of 5 pi over 4. That is equal to 1. Okay. By the way, kids always want to use this button right here. That notation, that -1 notation on a function is not a reciprocal. That's an inverse. We did inverses, remember? And so that -1 on a function is not a reciprocal, it's an inverse. And cotangent is not an inverse of tangent. It is a reciprocal of tangent, not an inverse of tangent. Inverse is completely different. Okay? All right. Cosecant is the flip of sine, so I'm going to be typing in 1 divided by sine of 5 pi over 6. That's what I'm typing in. 1 divided by sine 5 pi over 6 is 2. Okay. Secant is 1 divided by cosine. So 1 divided by cosine of pi over 6. 1.15470. At least 5 digits after the decimal point. Okay. Next up. Find an angle measure of theta in radians correct to at least 5 digits after the decimal point. So now we need to find the theta that gives us the 2/3 for sine. So sine of what angle is 2/3? Here's where we need to use the inverse, because if you have a function here, to get rid of a function, we inverse it, right? I will say that we're only going to get one angle here. Okay, find an angle measure. So just one. So I'm going to say, if we sine inverse both sides, I'm going to get theta is equal to sine inverse of 2/3. So in my calculator, here's where we're going to use our inverse button. Sine inverse of 2/3. This will give me one angle. Okay. For this one, theta will be tangent inverse of 9/2. Tangent inverse or inverse tangent, either way. So theta will be 1.35212. You guys, would it be correct to come up here and write equals 1.35212? Is that correct? No, it is not correct. You are telling me that 9 over 2 is equal to that. Are those two things equal? No, they're not. So do not write your answer up there. Write it down here, okay? Theta here will be cosine inverse of that decimal. So inverse cosine of 0.3617, 1.20070. Okay, next up we have secant of theta is 5/3. There's no secant inverse on our calculator, so I'm going to rewrite this. If secant of theta is 5/3, then what is cosine of theta? 3/5. So theta will be inverse cosine of 3/5. Inverse cosine of 3/5. 0.92729. If cotangent of theta is 3/8, then tangent of theta is 8/3. So theta will be inverse tangent of 8/3. Inverse tangent of 8/3. Cosecant theta is 2.5, so sine of theta is 1 over 2.5. So theta will be inverse sine of 1 over 2.5. Inverse sine of 1 over 2.5. And that's it. A nice short lesson for today. So that was a very brief review of the trig that you learned in geometry a couple years ago. You did much more in geometry for trigs, but this was the very beginning. Okay.